Hi, welcome back to my channel pibyme Maths. This is by WST01. Here we are solving January 2021 Statistics 1 paper. In part 1 of the video, we have covered question number 1, 2 and 3. Let's look at question number 4. A spinner can land on these numbers 10, 12, 14, 16 only, and the probability of the spinner landing on each number is the same. So if all the probabilities are same, it's basically a uniform distribution. The random variable x represents the number that the spinner lands on when it is spun once. State the name of the probability distribution. It's a discrete uniform distribution. Discrete uniform distribution. See, there are four numbers 10, 12, 14, 16. All the probabilities are going to be the same. So if they ask you to find E of x, usually for the discrete uniform distribution, the formula to find E of x is this, variance of x is this. Only when you have a number, natural numbers here. Okay, in this case the numbers are like 10, 12, 14, 16. So if you apply the method, the symmetrical method, symmetry, take the level of the symmetry here. This is minus 2, sorry, let's say 13 is here. From 13, it's 13 minus 1, 13 plus 1, 13 plus 3, 13 minus 3, and all the probabilities are same. So you can write E of x is straight away 13. You don't want to apply the usual method actually. You will still get the answer, but it's not worth your time. It's just a 1 mark question. So always remember, if the x are symmetrical about a middle point and the probabilities are also same or symmetrical, not necessarily be the same, it can be symmetrical also. What do I mean by that? Let's say here the probability is something like that. Some number here, P here, P here, Q here, Q here. So in that case, you can still take the middle number 13 as a probability of the expected value. In this case, all the values are 1 over 4. Okay, but to find the variance of x, you need to use the formula E of x square minus E of x whole square. E of x square is, you need to square x, multiply by this number. So you can take 1 over 4 as a common factor. You will get 10 square plus 12 square plus 14 square plus 16 square minus E of x whole square. So let's calculate this. 10 square plus 12 square plus 14 square plus 16 square over 4 minus 13 square. You get 5. That's all. That's variance of x. Let's move on to part B of the question. A second spinner can land on these numbers 1, 2, 3, 4, 5, and the corresponding probabilities are given here. Find E of y. Okay, you need to apply the formula here, sigma y times P of y. So you're gonna get 1 times 4 over 30. You need to show the working. 2 times 9 over 30. Maybe we can take 1 over 30 as a common factor. 1 times 4, 2 times 9, 3 times 6, 4 times 5, 5 times 6. Okay. 1 times 4, 2 times 9, 3 times 6, 4 times 5, 5 times 6 divided by 30. You get 3 as the answer. Now to find variance of y, the formula is E of y square minus E of y whole square. So E of y square, again you need to square all the y's and multiply by the probability. So again I'm going to take 1 over 30 as a common factor. 1 square times 4, 2 square times 9, 3 square times 6, 4 square times 5, 5 square times 6. That's E of y square minus E of y whole square. So let's calculate this now. 1 square times 4 is 4 plus 2 square is 4, 4 9s are 36. 3 square is 9, 9 6 are 54. 4 square is 16 times 4, 5. 5 square times 6. Divide everything by 13 minus 3 square, 9 over 5. That's all. Part D now. A random variable W is equal to AX plus B, where A and B are constants and A is positive. Given that E of W, I can replace W by this, is equal to E of Y. And variance of W, I can replace W by this. We know the formula for E of AX plus B is AE of X plus B is E of Y. Let's use the value of E of X and E of Y. E of X is 13, E of Y is 3 here. 13 and 3. So 13A plus B is equal to 3, equation 1. Here the formula is A square variance of X is variance of Y. So variance of X is 5. Variance of Y is 9 over 5. So 5A square is equal to 9 over 5. A square is 9 over 25. A should be positive square root of 9 over 25, which is 3 over 5. Sub in A here. So 13 times 3 over 5 plus B is 3. So B is going to be 3 minus 13 times 3 over 5 minus 24 over 5. Just leave it as a fraction. That's all. Let's move on to part E now. Each of the two spinners is spun once. Find the probability where W is equal to Y. Okay. First, what are the values X takes? If you read the question from the beginning, X is this 10, 12, 14, 16. 10, 12, 14, 16. We know W is equal to AX plus B, right? And A is basically 3 over 5. B is minus 24 over 5. So when you sub in X is equal to 10 and sub in the value of A and B, we can write W as 3 over 5x minus 24 over 5. Is it 24 over 5? Yes. You can write it as 3x minus 24 over 5. So when you sub in 10 there, 30 minus 24 is 6 over 5. Okay, I'm going to keep it as 6 over 5. When you sub in 12 in the place of X, 3 times 12 is 36 minus 24 over 5, which is 12 over 5. When you sub in 14, 3 times 14 minus, hope you understand what I'm doing here, divided by 5 is 18 over 5. When you sub in 16, 3 times 16 minus 24 over 5, which is 20. These are all the values of W now. Now what are the values of Y? From here the values of Y are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you see, none of the value, these are all the values of Y. We have to look for the values of W and Y which are same. There is no value, there are no values here in W and Y which are same, right? So you can write, therefore P of W is equal to Y is 0, because no values are same. What if there is an equal value? Let's say for example this is 2, for example. For some random value of a and b, it is 2. So when they say w is equal to y, that's basically w is equal to 2 and y is equal to 2, right? When the value of w becomes 2, when x is 12. So p of x is equal to 12 and y is equal to 2. Take the corresponding probabilities, whatever the probability is this, and then multiply. But in this case, you don't need to do that because no values of w and y are equal. So the probability will be 0. That's all. Question number 5 now. A company director wants to introduce a performance-related pay structure for her managers. A random sample of 15 managers is taken and the annual salary Y in £1,000 was recorded for each manager. The director then calculated a performance score X for each of these managers. Okay. The results are shown on the scatter diagram on figure 1. Okay, put the scatter diagram here. Describe the correlation between performance score and annual salary. As you can see here, there is a linear relationship, right? You can always draw a line of best fit with a positive slope here. So it's a positive correlation. So you need to write positive correlation. You can just write positive correlation, or you can say here the performance score, when it increases, the annual salary also increases, right? So you can write as salary increases as performance increases. You don't need to write this. As long as you write positive correlation, you will get a mark. Part B. The results are also summarized in the following statistics. Show that SXY is this. The formula for SXY is sigma XY minus sigma X times sigma Y over N. Sigma XY is this. All these formulas from chapter 5 are given in the data booklet, so you don't have to memorize them. Minus sigma X times sigma Y over N is, what is N here? Let's go back and read the question. They're talking about 15 managers, so N is equal to 15. So 19428 minus 465 times 562 over 15. You got the answer already. They want us to prove it's 2006. WI, find SYY. The formula is sigma y square minus sigma y whole square over N. Sigma y square 23140 minus sigma y whole square 562 square over N. 23140 minus 562 square over 15. 2083.7333. We might need this value later. So what I'm gonna do, I'm gonna store this value as X. So I'll put a little reference here, X. Let's move on to next part. Find the PMCC. You see, you definitely will need the value here. Part C. PMCC R is equal to SXY over square root of SXX times SYY. Is SXY here? Yeah. And SXX also here. SXY is 2006 over square root of 2492 times the value we just calculated, 208320. Don't use the rounded value. We have stored the value already in our calculator. We use the stored value. So it's going to be 2006 divided by square root of 2492 times I store the value as x. 88031, 0.88031 dot dot dot. So therefore R is 0.880. Part D now. The director believes that there is a linear relationship between performance score and annual salary. Apparently, when you look at this one, there is a linear relationship, right? Okay. Now the question says, state giving a reason whether or not these data are consistent with the director's belief. It is consistent, as you can write the PMCC is close to positive 1. That means strong positive correlation. Or you can write the points on the scatter diagram are close to a straight line. You can write this also, any one of this point. Part E now, calculate the equation of the regression line. Okay, to find the equation of the regression line, you need to find B first. The formula is SXY divided by SXX. Okay, SXY is 2006. No, that's SXY. SXX is 2492. 2006 divided by 2492. Let's get the value, and then we need to find A. The formula is y bar minus B x bar. Y bar is sigma y over n. Sigma y is 562 over n, 562 over n, and sigma x is 465, minus the value of B times 465 over n. So let's calculate the value of B first. 2006 over 2492. Gonna store this value as P. 8049 dot dot dot. So we put 8049 dot 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 here. But we use the stored value 562 over 15 minus, we have stored the value as B times 465 over 50, 12.512 dot dot dot. Therefore the regression line is, they want you to use the value of A and B to 3 significant figures. So A is going to be 12.5, B is 0.805x. We have the regression line here, part F now. Give an interpretation of the value of B. Value of B is same as the gradient. So basically in this line, when you replace x by 0, the value of y is 12.5. If you replace x by 1, the y value from 12.5, it increases by 0.805, right? So when you increase x by 1, y increases by 0.805. This is just for your reference. You cannot write this. You need to write what is x and y in this context. Let's go back and read the question. X is basically the performance score and y is annual salary, right? So x is the performance score. So for every 1 point increase in performance score, gives an extra, you cannot write 0.805. It's basically in thousands, right? If you read the question, in thousands. So when you multiply by 1000, when you multiply this value by 1000, it's gonna be 805. Okay, So gives an extra 805 pound increase in salary. You'll be given 1 mark for this. All these things are for your reference. Okay, that's the answer here. Part G now. Plot your regression line on the scatter diagram. We are not drawing a line of best fit. We are drawing a particular line. How do you draw a particular line? We learned that in coordinate geometry. Find the y-intercept. When you replace x by 0, you will get y is equal to 12.5. That's very important. Let's mark the point 12.5. 12.5 is, let's say, somewhere here. We got 1 point. We need 1 more point. Okay. Now, I'm going to sub in x is equal to the last point. X is equal to 50. So y is going to be 12.5 plus 0.805 times 50. Okay, 12.5 plus 0.805 times 50 is 52.75. That's the value of y. So it's almost equal to 53. And then just connect this line. You don't need to worry about anything else at all. You don't need to check whether we have equal number of points here, equal number of points here or not. Just a 2-mark question. As long as you mention this, another point and draw the line, you'll be given 2 marks. You don't need to do anything else at all. Let's move on to the next part now. The director hears that one of the manager in the sample seems to be underperforming. On the scatter diagram, circle the point that best identifies this manager. Okay, look at the scatter diagram. All the points are closer to the line. There are 2 points that are not closer to the line, right? But here, his performance score is this, his salary is this, right? But for this point, the salary is very high, but the performance score is not that high, right? So that's the point actually. So you need to circle this point. You just circle the point, you'll be given 1 mark for that. Now the director decides to use this regression line for the new performance related pay structure. Estimate to 3 significant figure the new salary of a manager with a performance score 30. So when x is equal to 30, you just need to find y. 12.5 plus 0.805 times 30 times 30. 36.65. But they want you to find the salary, and in the question it clearly says the salary is given as, here, is in £1,000. So you better multiply the value by 1000 and write the answer. So y is equal to this value times 1000. 36,650. They want you to round it to 3 significant figure. Therefore, y is equal to 36,700 pound. That's the answer. Question number 6 now. A disc of radius 1 centimeter is rolled onto a horizontal grid of rectangles so that the disc is equally likely to land anywhere. Okay, this is a disc with radius 1 centimeter. So the diameter is 2 centimeter. Okay. Each rectangle is 5 centimeter long, 5 centimeter long, and 3 centimeter wide. There are no gaps between the rectangles. That means you have several rectangles here, several rectangles. But we are just taking only one rectangle to better explain this. The grid is sufficiently large so that no disc roll off the grid. If the disc lands inside a circle without covering any part of the edges, then a prize is won. What do they mean by that? Okay, you're gonna throw this disc, and if the disc lands here, you get a prize. Anywhere here, you get a prize. But the moment it lands like this, like this, a little like this, you don't get a price. So it should be completely inside the rectangle, right? So we know the radius of the disc is 2 centimeters. So I'm going to copy this. You see the disc, I put 2 discs here, and the center is here, another center is here. This is basically 1 centimeter. This is 1, this also 1, right? So let's forget about this. And then the same way, since the radius, the diameter is 2, you can put 1 more disc here, and then 1 more here. It cannot go outside the rectangle, I cannot cover any of the edges. The same way the disc can land here also. So as long as the center is here or here, or the center is inside this little rectangle, that means if the center of the disc is inside this highlighted rectangle, you get a price, right? Think about it. Let me just delete the extra discs actually. The disc can land here, 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 anywhere you get a price. That means the center of the disc must be inside the yellow rectangle. The moment the center is outside, it's gonna cover the edge and you won't get the price, correct? So the center of this disc should be inside this rectangle to get the price, right? By considering the possible positions for the center of the disc, show that the probability of winning a prize. So probability of winning a prize is the area of this rectangle. So we know this is going to be now total is 5, so you leave 1 here, 1 here. This is 3 and 1. 3 times 1 is the area, and the total area is 5 times 3, so 1/5. But it's a 3-mark question. You just write this, you won't get 3 mark. You need to write why you have written this and this here. So you need to write the center of, you need to write a sentence mentioning that the center of the disc must land 1 centimeter from each side of the rectangle. And then you draw this little figure, find the probability. That's all, just a 3-mark question. Part B. A group of 15 students each roll the disc onto the grid 20 times. Okay. And record the number of times X that each student win a prize. The results are summarized as follows. Find the standard deviation. Don't use the 20. You need to use the n as 15. So the formula to find sigma is square root of sigma x square over n minus sigma x over n whole square. So 295 over 15 minus 61 over 15, the whole square. Find the square root of it. So square root of 295 over 15 minus 61 over 15 whole square. Okay. They want the answer to no level of accuracy is mentioned, so I'm gonna write it as 768866 1.768866 ... round it to 3 significant figure. That's all. So we might need the value, so I'm gonna store the value as A. So I put a little reference A. Okay, let's move on to part C now. A second group of 12 students each roll the disc onto the grid 20 times again, and the mean number of prize won. Okay, now you're saying for 12 students the mean is 3.5. Okay, so I'm gonna take it as y bar is 3.5 and the standard deviation is 2. Right, this is basically sigma y over 12 is 3.5. We can find sigma y which is 3.5 times 12, 42. Okay. Now find the mean and standard deviation of the number of prizes won per student for the whole group of 27 students. We already have X bar for 15 students here, right? X bar is, okay, we don't have X bar, we have sigma X. Sigma X is 61 and sigma X square is 295. This is for the 15 students. Now we need to combine them and find the mean and standard deviation of 27 students. So you take this and this, add them. So you get mean of 27 students is equal to 42 plus 61. That will give you the sum of all the 27 students divided by 27. That's going to be 103 over 27. 3.814. 3.814 dot dot. So when you round it, it's 3.81. Now we are going to find the new standard deviation for 27 of them. Okay. To find the new standard deviation, okay, we have sigma y here. Sigma y is 42. Now we have the variance, sigma y for these 12 students as 2, right? You can write it as sigma y square over 12 minus sigma y over 12 whole square root of it is equal to 2, correct? So you square both sides. Sigma y square over 12 minus this value is equal to 2 square. Bring this value here after squaring it, you'll get 4 plus 42 over 12 whole square. Make sigma y square as a subject. So 4 plus 42 over 12 the whole square, 65 over 4 times 12 times 12, you will get 195. That's sigma y square, right? So what I'm trying to do now, I'm going to find the sigma standard deviation of all the 27 of them now. Okay, so sigma, I'm going to put x plus y, all the 27 of them. So square root of sigma x square plus y square, right? Or for all 27 of them. So 295 plus 195 over 27 minus sigma x plus sigma y, 61 plus 42 divided by 27 whole square. You will get the standard deviation of all 27 of them now. Hope you understand this. So square root of 295 plus 195 over 27 minus 61 plus 42 is 103 over 27 square. 1.896 dot dot dot, so it's going to be 1.90. That's it. It's a 7-mark question. So what we are doing here, actually using this value, we are carefully finding sigma y first using this value, and then using this value here we are finding sigma y square, and then take sigma x plus sigma y, that's a sigma of all the 27 students, and then take this sigma x square and sigma y square, sum up, that will give you the sigma x plus y square, or you use a new variable z, sigma z square of all the 27 students. So use that to find mean and variance. Okay, let's look at part D now. The 27 students Also recorded the number of times that the disk covered a corner of a rectangle and estimate the probability to be this. What do they mean by that? When you throw the disk, right, the disk should cover the corner of this rectangle. You can put the disk anywhere inside this rectangle so that it covers the corner, right? Okay, think about it. Since the radius of this disk is 1 centimeter, we know the radius is 1 centimeter, right? So if the center of the disk is here, for example, so definitely it will cover the corner, right? If it's more than 1 centimeter from the corner, the disk will be like this actually. If the center lies more than 1 centimeter away from the corner, more than 1 centimeter away from the corner, it will be like this, right? Because the center is here. Because the center is here and it doesn't cover the corner, right? So to cover the corner, definitely the center of the disk should be 1 centimeter from the corner. So it can be here, 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 right? So it's basically forms a quarter of a circle, right? So if your center is in between here, anywhere inside this quarter circle, definitely think about it. If the center is anywhere inside here, you will definitely get the corner covered by the circle. But the moment the center is away outside the quarter circle, it will not cover the corner, right? So it's the same thing here also, same thing here also, same thing here also. So basically you are getting 4 quarter circles here. And since the length is 5 centimeter and the width is 3 centimeter, there is no overlap to these quarter circles. So these are all the required area where if you land the center of the circle, it will definitely cover the corner. So basically it's when you add up, it's 4 times area of a quarter circle, right? Pi, the area of a circle, radius is 1, so you get just pi, correct? So the probability is pi divided by the total area, which is what given as 0.2216. So pi will be approximately equal to 0.2216 times 15. 3.324. That's all.